Welcome to June 20th LeetCode Challenge. Short encoding of words. A valid encoding of an array of words is any reference string S and array of indices such that the length of words is equal to the length of indices. The referencing string S ends with a pound character for each indices at index I, the substring of S starting from indices at index I up to but not including the next pound characters equal to word at index I. So given an array of words, return the length of the shortest reference string as possible of any valid encoding of the word of words. So basically, a valid encoding of any word, a string of string S has to deal with the following, right? It has to complete three properties. The length of the index has to equal the length of the words, and each reference string ends with a pound character. So basically what we do here, we have the array of words here, time, me, and bell. So we want to return the length of the shortest reference string possible with a valid encoding. So say that we have the following. So we have time, pound, bell, pound. So that will give an indice of 0, 2, and 5. So this is a valid encoding, right? Because it fills this character here. We have another one where we have time is a substring of the start. The reason why, the rationale being this is a valid substring, is because you have time being a substring starting at indice 0, which has the basically the pound sign afterward, and which is given by the underline here. The word me is a substring of the word time as well, and that starts at index 2, or indices 1, which is the length of 2, and that ends with the pound sign as well. And then lastly, we have the word bell, which is followed by the pound character, ending in the pound character as well. Say we have the word called T, the string containing one character T, and the output would be 2 characters because we have to add a pound after the word T, and which is indices 0. So this would make this valid substring there. And we count this, so the length of the words between 1 to 2000, the length of the word at index I is between 1 to 7, and words consist of only lower English letters. So in order to solve this, we can kind of use a greedy approach using hash or sorted lists, but we can actually use a stored prefix approach. So if a word, let's say X, is a suffix of Y, then it does not need to be considered. For instance, we have the word me, which is a suffix of the word Y, which is time. So therefore, as an encoding of Y in reference, we can also encode X. For example, we have me and time, right? And it's in words, the words array. So we could actually get rid of the word me, right? And because that's already included in the word time, without changing the answer, right? The output answer. So if the word Y does not have any other word X in it, in the list of the words, that's a suffix of Y, then Y must be a prior referencing string. So for example, time and bell, these have nothing to do with each other, therefore they must be included inside they must be part of the reference string, because they have nothing that's overlapping with each other. Alright, so using those two approaches, thus the goal is to remove the words such that no word is a suffix of one another. So remove anything that's a suffix of another word. And the final answer would be essentially the sum of the length of the word plus 1 for word in words, essentially, right? So the algorithm starts off with the word is up to so we know that the length of word at index I has a maximum of 7 characters, right? So what we want to do is, since a word only has up to 7 suffixes, as per this condition, we might as well just iterate through all of them, and then for each suffix, we remove a letter, remove it from our word list for efficiency, so we make it a word set instead. So the code for this is pretty neat. So say that we have valid, right? Valid encoding, so valid. And this is going to be the set of words, I should say. And for word in words, we are going to find a for loop, do a for loop for, let's say, index I, the indices that we're going to range in the range of from 1 to the length of word. If it's valid, then we want to discard the word from the slice of I to the n. And this should all work out and return. So as I mentioned before, thus the goal is to remove words from the list such that there's no word that's a suffix from another. And this is what we did here. And then, so the final answer would be basically the sum of the length of the word plus 1 for word in words. Words in good, in the valid, I should say. So this should work. Alright. Excellent. Time complexity and space complexity is pretty neat as well. So time complexity is actually big O of n squared. Yeah, big O of n squared, where n is the length of the words in index I, because we have 2 for loops here. Memory complexity is big O of n, where n is used to store the suffixes. So we have the size of the set, big O of n. And that is it. Have a great day, guys.